transformations for the A&A SL course. So I'm actually going to start off on a website called Desmos. It's a really good website to explore functions, and I'd really recommend playing around in here if you haven't done so already, just to explore a new function, or if you just want to confirm that you've got some kind of transformation type question correct. So we're going to start off with Ffx notation. Most of the time you'd be used to putting in something like, something like that, right? Using just a y is equal to, but we're going to actually start off with an f of x, and we're going to start transforming that. So f of x is equal to, and let's think of a function. I'm going to choose something that will give us an interesting transformation. So something like that. Now we can see we've got some interesting properties to this too. Let's translate it up 3 or something, maybe even 2. And we've got that function there. Now, if you do want to also restrict the domain of your function, you can use your curly brackets, that's shift square brackets, and then we might want to go, okay, let's restrict it from, let's say x can be -3 up to 3, say for instance. All right, well, that's not going to look, there we go. And maybe we'll change that to -2 as well. Okay, so here we go. We've got our function here. Now we're going to do some transformations. G of x, and this is our new function, is equal to, and then we're going to start off with our simplest transformation, the plus d. Now you can go with slider here, and you can start moving around with this. You can also click in here, go step, and go like 0.5 or even 1, just so you can see the pattern easier. Now let's see what happens if I press play here. We can see that this function's going up and going down. So we can see that this function, the image of this object, we can see holds the same shape, but it's moving up and down. The technical term for this is a translate. Okay. Maybe we'll want to get rid of the d for the time being, and maybe we can change the next one, which is a. So add a slider for that. And I'm going to do the same thing, but I'll make it like 0.1, say. Press play, and we'll see what happens here. You can see this thing stretching, and then what seems to be reflecting. Okay, so let's have a look at this. If I go to 2, we can see that some values, this is at 2, it's gone to 4, right? This value here, 0.816 has gone to, 0.911 has gone to 1.823, approximately 2. We can also see that this key point here at 0 has gone to 0 as well. Not as easy to see there, but what's happening is that it's stretching along a vertical stretch along the y-axis, so it's a vertical stretch, by a factor of, in this case, 2. So if I move just to 3, we'd expect it to get even skinnier as it gets stretched along the y-axis like that. What happens if I start bringing this factor closer to 1? Well, we can see 1 is the same. That makes sense. It's getting stretched by a factor of 1. It's not going anywhere. Now, if I go 0.5, we can see that it's gone here. So all these y values are being halved rather than the y values doubling. You may notice the x values aren't changing at all. Next bit is if we go negative, we can see, I'll go -1. -1 is a reflection in the x-axis. So we can see that this point here, 2, 0, 2 has gone to 0, -2. So you're essentially timesing the y values by a -1. If I go further and change this to -2, for instance, I'm timesing my y values by -2, right? So this value 2 goes to -4, the zeros are staying the same. Now, these ones I think are the more intuitive ones. We're going to look at the less intuitive ones. Okay, so let's go plus C, add a slider, and let's see what happens here. I'll increment this one by 1 and press play. So we can see that it's holding the same shape here, it's moving around, but we can also see that it is moving side to side, but there might be something a bit counterintuitive here. When C is negative, we can see that the graph is on the right-hand side. When C is positive, like now, we see it's on the left-hand side. So that's a little counterintuitive. If we want to move the graph 3 this way, normally this is a negative along this x-axis, but we go x plus 3. This is because we're affecting the input firstly, and it's the inverse of what you think. So it's going to be x plus 3 is going to move it 3 left. Conversely, if I want to move it 4 right, I'm going to have to make c -4. So this function take 4, we'll move it 4 right. The next one, so this is a translation as well. The next one is b, and I think this is the most counterintuitive one. And I'll increment this one by, let's go 0.1. Press play and let's see what happens. I love that. Look at that. Okay, so we can see that it seems to be compressing or dilating along the x-axis this time. We're sort of squishing it in, then it stretches it back out almost like an elastic band. We can also see that it seems to reflect in the y-axis there sometimes. You may notice this happens when b is negative, so it reflects. Now, how far does it stretch? Well, this is the most counterintuitive bit. Let's bring it back to 1, so that's the same image. Now let's stretch it out to 2. Now, do you see as b's getting larger, which is here, we can see that the actual graph, for whatever reason, is actually getting compressed, right? So yet again, for b, like for c, it's affecting the input firstly. So it's an inverse operation. So it's not actually times in the x values by 2 like we'd expect, and it stretches all these, doubles all the x values. No, it actually times them all by 1/2. So b in this case is the reciprocal of the factor it's going in by. So it'd be 1 on 2. If I choose another value, like 1.5, here we go. Where's 1.5? There it is. So we can see it's been, again, it's been sort of compressed. This time it's 1 on 1.5, which is it's been compressed by 2/3, right? So you're taking the reciprocal each time. So how do you make it wider? How do you really stretch it along the x-axis? Well, you need to go in between 1 and 0. And we can see here that it's really stretching this out now. 1 on 0.5, we know 1 divided by 0.5 is 2. Therefore, we can see that it's doubling the x values. So 2 here is now going to 4. So we can see here that it's double the x values. The y values have stayed the same. Now, all of these reflect, sorry, pardon the pun, all of these A, B, C, D coefficients represent all of the transformations that we are concerned with. What we can now start doing is adding in the full function, right? And it looks something like this. Now, what we can do is just explore one by one, but we also need to know what happens when multiple things occur to it at once, okay? Now, the order for this is something called CBAD. So I think I can move these up and down. So this is the order, CBAD, of operations to tell us what will happen first, okay? So the C acts first, it translates first, then it dilates along the x-axis second, then it dilates along the y first, and then and then it translates up and down fourthly. Now, with that in mind, we're going to go back to the OneNote and we're going to take some notes, okay? But hopefully you found that useful, and you can muck around with this in your own time. So here we go, back to the OneNote. Let's do a little recap of what we learned. So we're going to make a table called the transformations. To start us off, we're going to consider a function that we're going to transform to practice. So this is a skill that we need to have, being able to transform a function that we might not be familiar with necessarily. It's just one that we have to practice transforming. And what I'll do is I'll bring that there, and okay, so hopefully we can see that okay. Yep, great. Where should I put it? I guess I'll just put it here in the middle. Sorry about that, I'm quite indecisive at the moment. Lovely. Now, we're going to draw in this function. So perhaps we might put here, let's just bring it in. So this might go here, then it goes down like this, and it continues. And then it might intersect over here, and then it might come up to here and stop here, okay? Now we're going to call this function f of x, okay? So that's our function notation. Now what we're going to do is we're going to do a bit of a summary. And I'm sorry, I'm gonna move this again. I'm just gonna put it here, and I think we can put the transformations to the right of it. Yeah, that'll work. All right, so the first transformation I reckon is the easiest one. So let's make a table. Okay, first thing is we have sort of the function notation. Then we have the description here. Then we're going to do a little sketch. And then we're going to have a look at what's happening to all the coordinates. Okay. So let's make this into a table now. There we go. So, first one we're going to have a look at is g of x, and I'm just going to call it different names for each one. Hopefully we can see that okay. G of x is equal to 2f of x. So we want to make a description of this one. First one, we can say that the effect of having a coefficient in front of f of x causes a vertical stretch by a factor of 2. Like that. Now another word for vertical stretch is we can also use the word dilation. They mean the same thing. So a dilation, in this case, if you want to say the word dilation, you say I say along the y axis, if you're going to use the word dilation. So a vertical stretch by a factor of 2, or a dilation along the y-axis by a factor of 2. Okay, so you can use either of those words. Now we're going to draw a graph of this. So if I did a quick sketch, and we're just going to copy this, and it's just going to be approximate all of these, we can see that each one of these values are going to double, so it's going to get steeper. So this point here stays around the same. Okay, so we're going to expect to see it sort of somewhere there, but then we're going to expect this to come up further, and it's going to be steeper as well. So it may look something like this, right? And then we can see that it's going to come here, this y value is doubled, and then it seems to shoot off more rapidly. So it might look like something like that. Okay, now this is function g of x. The next thing is what happens to the coordinates. Well, if your original coordinates is x and y, then the new coordinates, the image, is going to be x, 2y. Okay, so we're doubling all those values. The next one we're going to look at is going to be, and maybe I'll make that a little bit smaller just to fit everything in, just to make it a little bit more convenient. There we go. And then I can move that up a bit. Look at that use of technology. All right, the next one we're going to look at is this one, function h of x. Function h of x is going to be, let's have a look at a simple one, f of x take 2. F of x take 2. Oh, and apologies, the general letter we use for this one is a. Okay, we'll come to that later. Next one is h of x is equal to f of x take 2. So that's going to be a translation of f of x, and that's going to go 2 down, so 2 units downwards. Okay, and you can say vertically if you like. So this graph, what's it going to do? This one here is not going to change shape, so shape stays the same here. So what are we expecting to see? And this is going to be a bit smaller this time. We're expecting to see this graph over here, but it's moving down too. So we may see this graph now here. The shape stays the same, but it's just moved down too. So what's happening to the coordinates here? Your original coordinates, x, y, it's now going to x, y minus 2. So we're taking 2 off each of the y coordinates, like we can see in this diagram here. It's kept the same shape, they're just all moving down too. So we've done the nice ones. So these functions here are ones that, these transformations here affect the output. So these are pretty nice ones. And I'm just going to write the letter we use for this. Take d, so plus d in this case. So d is the value that moves up and down. The next one we're going to have a look at is function j of x, and this is going to be x plus c, and in this case let's make our c take 3, and this corresponds to the letter f of x plus c. So what's this going to do? It's going to be a translation of f of x 3 to the right. The shape's staying the same in this one, so the entire graph is going to move to the right. So I'm going to change my axis now just to fit it in. We're going to see all our x values adding 3 to. Adding 3 to. So this is a counterintuitive one. If it is take, you're going to move to the right. So where's our graph going to end up? Well, if it might be somewhere over here, for instance. And yet again, this is just a rough sketch. It's being moved 3 this way. Okay, now what's happening to the x values in this case? X and y? Well, the x values are having a 3 added to them, and the y stays the same. Right? Now, the next one we're going to look at is going to be our b value. So let's scroll down and have a look at that. So we're going to call this jk of x is equal to f, and we're going to make this one 2x. All right. Now, what letter this corresponds to is b, bx. What this does is we can say dilates by a factor of 1 on 2 along the x-axis. Okay, dilates by a factor of 1 on 2 along the x-axis. Now the general dilation factor here, if we're going to talk about f, is going to be it's dilating 1 on b, i.e. the reciprocal along the x-axis, right? So that's why if you've got 2, it actually all the x values halve. So if I'm looking at this function here, what we're actually going to see is it's going to compress, it's not going to stretch along the x-axis. So what are we going to see? We're going to see this function up here, all the x values are going to get halved, right? So it's actually getting compressed, if you want to think about it. So it may look something like this. So everything's getting squished together by a factor of 2. Okay, so what's happening to the x values? You can say it's x, y, and what's happening? You've got the x's are, in this case, being halved. Okay, now you may want some general rules for all these things that we're looking at here. If this is the one you want here, the general one is xy is going to xay. Down here, if you're adding d, then this one's nice and straightforward. xy plus d. The next one, I've got no room for this one. Might chuck it here. Maybe I'll just see if I can squish this part just to fit it in. There we go. We've got xy is going to, and this one's going to go to x take cy, so it's the opposite of what you think, and this one is going to be xy is going to x times by 1 on b, oops, I just did a fraction, old habits die hard, over y. Okay, now what we have here is we've got our main transformations we want to look at. We're going to look at 2 other special cases, okay, and these are called the reflections. Okay, so I extend this 1, 2. All right, and then we've got a table of all our transformations. So let's look at our next function, which is jk. Let's go L. L of x is going to be this function here. It's going to be negative f of x. Now this one here represents a reflection in the x-axis. Now this one's sort of easy to remember because this is where normally a would affect. We can think of a as -1. So all our y values are being times by -1. So the effect of this is a reflection in the x. So we had this original function up here, and then all these values are just going to reflect over this axis here. Okay, so let's draw that in. Should have the same point here. This is going to stay here because we're reflecting along that line there. And we've got that hollow circle there. And then what happens after that? It seems to be like reflecting over here and then going down, I think, like that. So it's reflecting over that, and I'll change the color on this. It's reflecting over this axis here. Just drawing that in orange. Okay. Now what's happening to the coordinates? Well, we don't need a general rule here. It's just x and then -y. So whatever coordinates, it just makes negative. The last one we're going to look at is a reflection. It's another kind of reflection. So JKLM, m of x is equal to this function, but we're going to take a negative of the input. Now what does this do? It causes a reflection in the y-axis. Okay, so if I drew this out, it's going to be reflecting over this axis here. Okay, so hopefully this all loads up pretty soon, because it isn't at the moment, and I'm just talking to a blank screen. Come on, you can do it. Okay, there it is, very slowly appearing. Very exciting. Well, I'm just going to keep drawing while we wait for that. Okay, so this goes over here. Wow, that is taking a long time. Oh, here we go, here we go. A, next letter's X, I reckon. Oh wow, they did a lot then. Okay, now a picture's going to appear. Oh, here it is. I'm hoping a vertical line comes down. It might. It's thinking about it. Nah, I'm too tired today. There it is. Okay, now while that's going, I'll put up the rest. X, Y. Oh, now it's loaded up. So over here's the coordinates. We can see that xy is going to go to -xy. Eventually. Cool. It's always great when it happens at the end of the video. Lovely. There we go. Oh my goodness me. I am so sorry. My iPad talks to my laptop, and it isn't doing that at the moment. There it is. Okay, now I'm going to end the video here. In the next transformations recap video, we're going to go through combining transformations and then looking at how we can transform coordinates and also functions. Okay, thank you very much for watching. I hope this was useful in some way.